Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Hello dear students, welcome to Pen and Paper Chemistry. Thermodynamics part 17, 16 videos are already in place in this particular playlist. The heading we are covering in this video is Gibbs energy and predicting feasibility of a process. Now, under the second law of thermodynamics, we had predicted feasibility of a process in terms of the total entropy change. Entropy change of the system plus the surrounding is greater than 0, process is spontaneous, less than 0, non-spontaneous, equal to 0, process is in equilibrium. That is, forward and reverse reactions are taking place simultaneously. Now, in the previous video, we had derived the relation delta G is equals to delta H minus T delta S, and also delta G is equals to minus T delta S total. Now, if I'm saying that for a spontaneous process, delta S total has to be greater than 0. Now, delta G is equals to minus T delta S total greater than 0 means it's a positive value. Positive value, let's say 500, right? So this gives me a negative value, plus into minus gives me a minus value, minus 500 T. In other words, if a process is spontaneous, then my delta G will be less than 0. See, it's a negative value. Delta S total, if it is less than 0, the process is non-spontaneous. What happens to the value of delta G then? Now, when I am saying delta S total is less than 0, that means it's a negative number. Minus into minus gives me a plus. In other words, for a non-spontaneous process, delta G becomes greater than 0. That is what we have written over here. If this delta S total is equals to 0, that means minus T into 0. Anything multiplied by 0 becomes a 0. That means delta G is equals to 0 for a process which is in equilibrium. Now, just going back to the non-spontaneous process, if I am saying that for a process delta S total is less than 0, delta G is greater than 0, the process is non-spontaneous. So for example, I am saying breaking down of HCl to H2 and Cl2. Now this is a process where delta G is greater than 0 for this particular process. So what will happen for the reverse process? Reverse means I am talking about H2 plus Cl2 combining to give me 2HCl. So delta G will become less than 0 because we are talking about the reverse process. So what will happen is, in such a case, it is the reverse process which is spontaneous. I hope this makes it clear how to correlate delta S and delta G in terms of spontaneity, in terms of predicting the spontaneity of a process. So if delta S is greater than 0 or a positive value for a spontaneous process, it is a negative value of delta G which decides the spontaneity of a process. Further on, delta G is equals to delta H minus T delta S. Is only entropy responsible? Yes, it is, because there we are talking about total. But if you remember here, delta G is equals to delta H minus T delta S. In this particular expression, we are talking about the entropy change of only the system, enthalpy change of only the system. Now, let us see how the value of delta G changes under different processes, under different conditions. I have taken two examples over here, exothermic process and endothermic process. Exothermic process, that means delta H is negative. Endothermic process, delta H is positive. Now let's try and understand each one of these one by one. delta G is equals to, now this equation of mine gets modified to become delta G is equals to minus delta H minus T delta S. Here either delta H can be greater or T delta S. If my T delta S is a positive value, that means it is greater than 0. So delta G is minus delta H minus T delta S. This particular reaction becomes spontaneous. Delta G is less than 0. In other words, this is a process which is being supported by enthalpy. There's a decrease in enthalpy. It is a process which is being supported by entropy as well. So entropy, there's an increase in entropy, there's a decrease in enthalpy. Delta G overall is spontaneous. The process is spontaneous at all temperatures. Come to the second case where T delta S becomes negative. If you remember, we've taken only delta H as negative. T delta S is negative. That means it's less than 0. So this equation of mine gets modified to delta G is minus delta H. Minus into minus becomes plus and plus T delta S. Now whether delta G will be less than 0 or more than 0 depends on the numerical value of both of these. So let's suppose if I have minus 3 plus 1 and the other is I have minus 3 and let's say plus what value do you suggest we take? We're talking about high temperature, that means T delta S becomes greater. So minus 3 plus 5. Yeah. So here we have minus 3 plus 1. So that means we're talking about a condition where T delta S is a small value. In other words, we're talking about low temperature. So T delta S is less than delta H in terms of numerical value. So my delta G becomes less than 0. The process is spontaneous. Here I'm talking about minus 3 plus 1 is the example. The other is if I have high temperature, because of which the T delta S value becomes greater than delta H in terms of its numerical value. So my delta G becomes greater than 0. The process becomes non-spontaneous. We have an exothermic process which is spontaneous at low temperature, non-spontaneous at high temperature. So when we are talking about the feasibility of a process, temperature also plays a role in deciding whether the process is feasible or not. Now, for the endothermic process, would you like to pause the video and work on it yourself rather than just copying and waiting for me to make you understand? Just try it yourself. Endothermic process, delta H is positive, so your equation becomes delta G is equals to delta H minus T delta S. Again, take the two conditions, whether this one is bigger or smaller, if it's a positive value or a negative value. Just pause the video for a minute. See if you can do it yourself. Okay. If you've done it, would you like to check whether we are on the same platform, whether we've understood or not? So we have T delta S is less than 0. Less than 0 means it becomes a negative value. So what do we have is 2 minus minus 3. Minus into minus gives me a plus. So I have a positive value. Delta G becomes greater than 0. The process is non-spontaneous. Come to the second case. T delta S is greater than 0. That means it's a positive value. So delta G is equals to delta H minus T delta S. Again, there can be two possibilities over here in terms of the numerical value. Delta H greater than T delta S. So let's suppose I have 5 minus 3. So delta G is greater than 0. The process is non-spontaneous. Now this will happen only if either the temperature is low or delta S is small. So that means at low temperature this process is not feasible. Come to the second possibility. T delta S is greater. So let's suppose this is 3 and minus 5. I'm just talking about the numerical values. For the signs, for the positive and negative signs, we've already taken it step by step. Now this comes out as minus 2. In other words, your delta G is less than 0. The process is, yes, spontaneous. And this is possible if either the delta S value is large or the temperature is high. So if you notice over here, even an endothermic process can become spontaneous at high temperature, right? So this overall helps to explain the feasibility of a process. Now if you notice, we've done away with the entropy of the surrounding when talking about the feasibility in terms of delta G. So our delta G, that is Gibbs energy or Gibbs energy function or Gibbs function, has an upper edge compared to the entropy change in order to decide the feasibility of a process. We shall continue relating Gibbs energy to the reaction constant in the next video, part 18 of thermodynamics. Till then, happy studying to all of you. If you have not done so as yet, please do subscribe to the channel Pen and Paper Chemistry. The only mission of this channel is to make learning chemistry easy and fun for all you students, with the help of the periodic table, the flowcharts, the graphs, diagrams, dealing with numericals, how to deal with numericals. And this can only happen when you keep a pen and notebook ready so that you can also take down notes for offline reference. There is no subscription to join the channel, there is no payment at all. Only request is to help spread a word about the channel by sharing it with friends, classmates, juniors, seniors, so that chemistry can be easy and fun for one and all. See you in the next video.